Welcome to the Hitchhiker's Guide to Calculus. My name's Kevin, and I'll be your guide to evaluating any limit on the AP exam. Now we're just going to do a decision tree here. So when you see any limit, it's going to fall under one of two categories. The limit as x approaches a of f of x, or the limit as x approaches infinity of f of x. Both of these are their own separate case. So if you ever run into a question that asks you the limit as x approaches a of f of x, the first thing that you should always do is just plug in a. When you plug in a, you're going to end up with one of three possible outcomes. Let's look at the easiest outcome possibility first, and that's if we get a value of L, meaning just any real number when we plug in a. If you get any real number when you plug in a to your limit, you're done. No further steps necessary. You can just say that the limit as x approaches a of f of x is going to equal whatever value you got. Now, this almost never happens because this is way too easy. So I wouldn't ever assume that it's going to work out nicely like this. More often than not, when you plug in a, you're going to get 0 over 0 or our other option, but we'll focus on 0 over 0 first. When you get this, it should indicate to you that there is some simplifying to be done. This could mean one of several things. Lots of times you can just get away with factoring. You might be able to simplify by using the conjugate. You might need to get common denominators and combine fractions in a unique way to simplify. Or you might even be able to use trigonometric identities to simplify. And these are just a few of the possibilities, a few of the more common possibilities. Right? But once you simplify your expression, your goal is still to plug in a and hopefully get an actual real number out. So once you simplify, you just go back to the start and you plug in a again and see what happens. Now, you might get any of the three options again, but hopefully you end up getting a real number L, and that'll be your limit. But if at any time you plug in a and you end up with c over 0, where c doesn't equal 0, so 5 over 0, negative 2 over 0, any number over 0, this is not going to be a simplifiable situation. We've seen this before. We know when you divide by 0 and it can't be simplified out, you're going to have a vertical asymptote in your function. And this is nice because there's not a lot of options that could happen. When you have a vertical asymptote, your function has to go up that asymptote or down that asymptote. Those are only two options. So when this happens, we're going to check values that are around a. I need to check the limit as x approaches a from the left of our function and the limit as x approaches a from the right of our function. This is one of the only instances where you're not going to be able to plug in a. We know plugging in a gets us an undefined broken function. So we're going to test values that are a little bit to the left and a little bit to the right. So you literally get to pick just a value that's kind of left and kind of right of a. And we're going to see whether we get a positive or a negative value out. Because of this, if we end up getting a negative value from plugging in our test value, we know our answer is going to be negative infinity. If we get a positive value from plugging in our test value, we know our answer is going to be positive infinity. And if we check the overall limit, maybe they don't agree, and our final answer would be does not exist. But these are our only three possibilities for when we get this vertical asymptote situation. Next, let's check out the other branch of this tree. What happens when the limit as x approaches infinity of f of x? What do we do here? Well, granted, I guess this could also be when x approaches negative infinity. Right? Both cases should warrant the same response. Right? When I see these questions, I'm thinking, what is the end behavior of my function? Because we're looking for what's happening all the way to the right or all the way to the left on my graph or my function. So lots of times this is a question about, is there a horizontal asymptote to our function or not? And now we have other videos regarding precisely this that give you some shortcuts to doing that, but this is just a general overview. So all we need to know is that when we see this type of limit, we are just looking for the end behavior, and there's only three possible outcomes that could arrive from looking at the end behavior of a function. Right? We could end up going towards the horizontal asymptote, in which case our limit would be the horizontal asymptote. Right? If our function doesn't approach the horizontal asymptote, then it has to be going up forever or down forever. So our other two possible options would be positive infinity or negative infinity. And those are the only three possible ways that this story could end on this type of limit. If you want to see some examples of how to evaluate these and tips and tricks, shortcuts, make sure to check out the video that should be popping up right about now. And you'll also find some links in the description below to take you to some other examples that should help. Don't forget to hit subscribe and like the page to get alerts about all the content we release each week.